Okay, let's jump right into this explainer. Today, we're taking what usually looks like a dry, boring reference list of Linux commands and transforming it into a real-world, practical survival guide for your daily server workflow. Because look, if you spend your day managing systems, you know firsthand that these aren't just commands you memorize for a test. They're quite literally the only thing standing between a smooth, productive workday and a complete IT meltdown.
Here's the game plan for today. We're going to cover essential system baselines, monitoring server health, emergency memory management, network and process tracking, and finally, storage and file systems. We're treating this exactly like a practical day in the life of an IT pro, moving from those routine morning server checks all the way to handling high-stakes emergencies.
So imagine this for a second. Your server is actively crashing and you have thousands of users waiting on you. What is your literal first move? It's a totally panic-inducing moment, right? But before you can even attempt to fix a crisis like that, you absolutely have to understand the exact state of your system. And that brings us to our first set of tools. Section 1 is Essential System Baselines, which is all about getting your bearings. Before we do anything else, we establish baselines, kind of like a pilot running through a mandatory pre-flight checklist.
The very second you log in, you want to fire off these rapid-fire commands. Use W, who, or who am I to immediately see exactly who else is poking around in the system. Check your temporal state with date and let uptime tell you how long the server has been running alongside those absolutely crucial 1, 5, and 15-minute load averages. For system identity, uname -A and -R will pull your OS and kernel versions while checking that Red Hat release file gives you the highly specific OS version.
Now, when you need to look past the software layer and inspect the actual bare metal, these foundational commands give you an instant snapshot. DMI code dives deep into your hardware information, while simply printing out CPU info and mem info from the /proc directory gives you the raw, unfiltered specs of your processing power and memory capacity.
Moving into Section 2, Monitoring Server Health. Basically, we need to know, is the server sweating? When traffic spikes unexpectedly, you need to know exactly how much pressure the system is actually under. A great way to think about this is imagining your CPU as your office workers and your memory as your desk space. The top command gives you live CPU utilization, showing you exactly how incredibly busy your workers are in real time. Meanwhile, free-m displays your memory utilization in megabytes, telling you exactly how much desk space those workers have left to operate. And for a much broader look, SAR provides a general system activity report so you can start spotting trends over time.
Now, when you need really deep statistics, vmstat is going to be your best friend. Pay really close attention to the R under procs. Those are your running processes desperately waiting for runtime. Also keep an eye on US under CPU, which shows the user's CPU time spent running non-kernel code. Tracking these specific metrics helps you instantly spot exactly where your processing bottleneck is hiding.
But hey, what if the CPU isn't the problem at all? It might actually be your disks. IOStat gives you the tools to figure that out. The first section gives you a CPU report. Look out for %IO wait, which indicates your CPU is just sitting there completely idle, waiting for a disk request to finish. The second section is device utilization. Here, TPS gives you your transfers per second, and those block read and write metrics help you pinpoint input and output issues. Bottom line, a higher TPS simply means the processor is working harder. All right, Section 3, Emergency Memory Management. This is all about handling the crisis. When memory actually starts to fail, it is time for practical, decisive intervention. Treat system cache like a bunch of sticky notes covering a computer monitor. If it gets way too cluttered, you need a way to clean it up safely. You can follow these precise steps using the drop caches file. Echoing 1 clears the page cache, echoing 2 clears your free Directories and Inodes, and echoing 3 safely removes all caches. This gives a suffocating system some much-needed breathing room. And that brings us to a massive, absolutely crucial real-world business rule. If you have a swap issue, you use swap off-A and swap on-A to manage it safely. But listen closely. Never clear swap during peak business hours. I mean it. Doing so can cause your active processes to crash and completely derail the entire workday. You always save this procedure for before or after hours. No exceptions. Section 4 is network and process tracking, or as I like to call it, finding the culprit. When things inevitably go wrong, you have to know how to track down rogue network connections or those runaway processes. When a specific service starts throwing alerts at you, use these commands as your magnifying glass. You can search for a specific Java process using ps-ef pipe to grep Java to find its exact process ID. Once you have that ID, strace acts as your ultimate magnifying glass, letting you see exactly what that process is doing under the hood. To verify your networking, netstat-anrar checks your default gateways, and ifconfig quickly grabs your IP address. Oh, and if you ever forget a flag, just use man to pull up the help documentation for literally any command.
Finally, Section 5, Storage and File Systems. This is about organizing the warehouse, rounding out our practical workflow by managing the physical files and storage architecture of our system.
To maintain absolute order in your storage warehouse, use df for a high-level view of your entire disk, and du to zero in on the specific directories that are eating up all your space. Can't find a file? Locate finds its path instantly. Need the gritty details? Stat dives deep into the file statistics. Running out of room? gzip and gunzip are right there to quickly compress and uncompress your files on the fly.
Now, for advanced file management, sed and awk are basically your surgical tools. They let you stream edit and analyze really complex log files directly from the terminal. Instead of opening up a massive, clunky text editor, sed stream edits on the fly, while awk lets you slice and dice file columns and rows in highly specific ways to extract exactly what you need. It's a real game changer.
But understanding storage requires actually understanding Inodes. These are essentially the unique, permanent ID badges assigned to every single item in your file system. Every single time a file or directory is created, an inode is generated. You can check these reference numbers using ls-li for files or df-hi to view inode usage across your entire disk system.
Now, this brings up the difference between links. Think of a soft link as a sort of fragile cross-system shortcut, whereas a hard link is a robust backup that shares that exact same inode we were just talking about. If you delete the source of a soft link, boom, your shortcut breaks. But because a hard link shares the exact same inode within the exact same file system, deleting the source means your destination file is still perfectly accessible. So, we've built a seriously practical toolkit today, but it really leaves you to wonder just how intimately you know the invisible architecture powering your own daily work. Ask yourself, if your digital infrastructure completely failed today, would you know exactly which command to type first? Mastering these tools transforms you from someone who just frantically reacts to problems into a true systems administrator who confidently manages the workflow. Thanks for joining me on this explainer, and definitely keep practicing.